Okay, this is a very simple topic, and if you are in honors chemistry, this is a no-brainer. However, if you are not in honors chemistry, then you probably have no idea about these significant figures, which we just call sig figs for short. There are four very important rules you must know about sig figs. The basic goal is to identify how many significant figures are there in a number. And basically what a sig fig is, it's all the numbers you know for a fact with one uncertain digit. That's the number you're not quite sure about, and we'll go over that as well. First, let's just identify how many sig figs there are in each one. So let's pull out this. There we go. The very first rule says every single number, every single digit that's a non-zero is a sig fig. So for example, in the first example right here, 7,600, there are two, the 7 and 6, there are two non-zero digits. Therefore, there are two sig figs. So again, these zeros don't count. Rule number one states all numbers, all digits that are not zero are a sig fig. That's the easiest rule. Now, the other three rules are all about zeros. Can a zero be a sig fig? Yes, but there's different rules as to when they are sig figs. So let's go to the next example. The next one even specifically says 7,600 again, but this time this zero has a bar over it. And the rule is any zero with a bar over it is a sig fig. So in this number, there are three sig figs. And the reason why is there are two non-zero digits, so there's 1 and 2. This zero has a bar over it, therefore it's a sig fig, that makes it 3. This zero has nothing special about it, it does not count. So there are three sig figs. Let's go to the next one. 48,934. Well, there are 1, 2, 3, 4, 5 digits that are not zero, so there's 5 sig figs, and there's no zeros anywhere else, so I know it's just simply 5 sig figs. Okay, so again, to reiterate, the first rule says any digit that's not zero is a sig fig. The second rule states any zero with a bar over it is a sig fig. The third rule states that any zero in between sig figs are sig figs. So for example, you have 100,003. You have 1, 2 sig figs here, the 1 and the 3, because they're non-zeros. These zeros don't have any bars over them. However, they are in between two sig figs. Now I gotta be careful. I don't want to say two non-zeros because I'll do an example later on. But these 4 zeros are in between two sig figs, which means they are also sig figs. So in this one, there are 1, 2, 3, 4, 5, 6. 6 sig figs. You have 2 non-zeros and then 4 zeros that are in between sig figs. 40,300. Okay, there are 1, 2 sig figs that are non-zeros. There's 2 sig figs here. This zero has a bar over it. There's 3 sig figs. This zero doesn't have a bar, but it is in between sig figs, so therefore that does count. This zero, there's no bar, it's not between sig figs, it does not count. So this one is 1, 2, 3, 4 sig figs. Alright, now going back to another example, I also want to do this one real quick. How about, I was like the number 4. 40,300. And I put a bar over that one. This one would also be 5 sig figs. And here's why. You have 1, 2 non-zeros. You have a zero with a bar over it. This zero is in between sig figs here and here. Or I can even say it's in between the 4 And this is a sig fig because there's a bar over it. This 0 is in between sig figs. It's in between the 3 and this 0 that has a bar over it, or it's in between this 4 and the 0 that has a bar over it, or because since this is a sig fig, it's in between this 0 and this 0. So there's all sorts. It's a little tricky here. But in this case, there are 5 sig figs. So I don't always want to say, oh, it's whenever zeros are in between non-zeros, because that's not true. This 0, or if I even did this one, I'll just do this one. Whoa, that's a 0. That's a 0. There you go. 100,000. They're all sig figs because the 1 is a sig fig and this 0 that has a bar over it's a sig fig, and these are all in between those numbers. Therefore, they are sig figs. So there's 1, 2, 3, 4, 5, 6 sig figs. So those are again the first 3 rules. Any non-zero is a sig fig. Any 0 of a bar over it is a sig fig. And any 0 in between sig figs are a sig fig. The last rule, which is one of the tougher ones, it's like 2 rules in 1, says this. Any 0 that's to the right-hand side of the decimal, I'm going to repeat that, it has to be to the right-hand side of the decimal and also has to meet both parts. To the right-hand side of a sig fig are significant. So I have 7.60. This 7 and 6 are non-zero, so there's 2 sig figs. This 0, there's no bar. It's not in between sig figs. However, it is to the right-hand side of the decimal, and it's to the right-hand side of a sig fig. Whether it be the 6 or the 7, it doesn't matter. This 0 is to the right-hand side. Again, it's to the right-hand side of a decimal point and to the right-hand side of a sig fig. Therefore, it counts, and there are 3 sig figs. 0.3010. Okay, there are 2 non-zero digits. Easy. This 0 is in between sig figs, and not only that, but it's also to the right-hand side of the decimal and to the right-hand side of a sig fig, so it counts that way. This 0 is to the right-hand side of the decimal and to the right-hand side of a sig fig, so it counts, so these 4. This 0, there's no bar over it. It's not in between sig figs, and it's on the left-hand side, so that does not count. So in this one, there's only 1, 2, 3, 4 sig figs. Last one, 0.00420. Okay, again, I have 2 sig figs here, 2 non-zero digits. That's an easy one. This 0 does no bar over it. It's not between sig figs. It's on the left-hand side. Does not count. This 0, no bar. It's not in between sig figs. Yes, it is to the right-hand side of the decimal, but it is not. I repeat, it's not to the right-hand side of a sig fig. So this 0 does not count. That 0 doesn't count. This 0, it is to the right-hand side of the decimal, and it's to the right-hand side of a sig fig. So this last 0 does count. So there are 3 sig figs for that one. Let me erase this real quick. So just to say that again, there are 4 rules for sig figs. Any non-zero digits is sig fig. Any 0 with a bar over it is a sig fig. Any 0 in between sig figs are sig figs. Any 0 to the right-hand side of the decimal and also to the right-hand side of a sig fig is a significant figure. And a lot of times, when you get to the math part, you have to make sig figs, and we'll talk more about how to turn a 0 into a sig fig like that. Like, for example, if I say, whoops, hey, you have the number 300. How many sig figs? Oh, there's 1. If I said, make it 2 sig figs, you'd be like this. Oh, boom, bar over that 0. Boom, boom, sig fig. If I said, make it 3 sig figs, do not do this. Do not put a bar over both zeros. You don't do that. You only need the bar over the very last sig fig. That would make 3 sig figs because this is a non-zero, this 0 has a bar over it, and this 0 is in between sig figs. The last thing I want to talk about is the uncertain digit, and this will help explain sig figs as well. The uncertain digit is the first sig fig going towards the left-hand side. So that's my way of doing it. There's a couple other ways you could say it, but my favorite way of saying it is it's the first sig fig going towards the left-hand side. Now, the uncertain digit, the whole meaning of it is that's the one digit you don't know about. That's the one you're estimating. All the other ones you know for a fact. So for example, in this first one, 7,600. The very first sig fig I get to going to the left is the 6. That means that's the number I'm not sure about. I know for a fact it's 7,000 something, but it's 7,600. The 6, that hundreds place, is an estimate. So it could be 7,400. It could be 7,800. It could be 7,328. It doesn't matter. I know for a fact it's 7,000 something. I just don't know about that number. So the more sig figs you have, the more accurate your number is. The more sig figs you have, the more accurate the number is. So in this case, the 6 is my uncertain digit. If I do the same example here, okay, 7,600, but with the bar over here, the first sig fig going to the left-hand side is this 0 with the bar over it. That's my uncertain digit. So what this says to me is, I know for a fact it's 7,600 something. It could be 7,642. I don't know. Basically, it's like where I round. I round it at the tens place because that's the one I'm not sure about. And this number, 48,934, the first sig fig going towards the left is the 4, the ones place. So I know for a fact it's 48,930. I don't know. Could be 937, 932. I don't know. This is the number I'm uncertain about. That's why it's called the uncertain digit. So you get it? What about this number? Which is the uncertain digit? Good job. You're exactly right. It's the 3. The 3 is the first sig fig going towards the left. Good job. Next one. What about this one? Yes, exactly. It's the 0 with the bar over it. Okay, the 0 with the bar over it. That's the first sig fig going towards the left. That's my uncertain digit. This one would be the 0 here. Okay, again, because this is a sig fig. This one, remember, if you remember, there's 3 sig figs. This is the first sig fig right here going towards the left, so it's that 0. Same thing with these last 2. It's the 0. It's the 0. So again, uncertain digit, it's the first sig fig going towards the left. Well, 13 minutes on sig figs. Have fun with watching this. Bye!